Okay, I wanted to show you, need your attention, friends. I wanted to show you up on Schoology that I have put up there both this study guide that I just handed you, the Chemistry Unit 1 study guide, as well as I have told you that your first assessment for this, your first summative assessment will be on Thursday for this class. This outline is showing you what that assessment will be over. Over the labs we did, over the POGIL, over the stuff we'll talk about today and tomorrow. Some other pieces between now and Thursday we will still work on, but just so you know, this is the plan, is that Thursday will be our first assessment time together. You had an opportunity to see the questions as well as the answers for that little formative assessment that we just took over your reading. Remember, friends, I promised you I won't assign you reading without actually giving a way for you to show me that you know what you read, right? And I would push you a little bit, just a little bit, that if you weren't able to answer those questions all the way, I would say two things. Number one, I want you to read a little bit deeper, like for understanding, not just for your eyes to go over the page. And number two, I like it when you mess up. Oh, wait, what? Because you'll remember. You'll remember those definitions of those pieces you missed better than the ones you got right, which is a funny thing. That's what the research has shown us. So as a teacher, I almost want you to fail so you'll remember it. That's okay. So don't be afraid. It's only a couple of points. Will hurt you very little in the long run if you didn't get them all right. Okay? So let's pop in here. We'll do some conversating here. If you want to go with me in your textbook, we're looking at chapter 2.3, that begins over on page number 47. If you want to go there with me. Page 47. 2.3 if you're using the electronic textbook, or page 47 in your regular textbook. If for maybe some reason you don't have a textbook here today, share with your neighbor. Okay? Or oh, it's right there. Good, yes. Excellent. Okay. We're going to talk about first accuracy and precision. So, 47. So, I ask you, what does it mean to be accurate? Give me a raised hand. Yes, ma'am. Okay, how close you get to the target. Is there another way you want to say it? Okay, so consistency I'm going to hold off on because that one's actually precision. That's about the consistency. But did you hit the target? Did you get that one that you were trying to get? That's where she's going at. Any other ways you all want to say what accuracy is? How about what does a textbook say? Someone want to read me what it says there for accuracy? Sir.
How close a measured value is to an accepted value?
So it's measured value, what you measured, to the what? Accepted, to whatever the standard is. Does that make sense? You take this box of Kleenex that we know weighs 1 pound. You put it on a scale, sure enough, it weighs 1 pound. You are accurate. Does that make sense? Saying, yeah, Mr. Hess, he's about 10 feet tall. Accurate? Not really. Right? Not really. Not really. I'm not quite that tall. Does that make sense? So accuracy, is your measured equal your actual? Is that really what it's supposed to be? Or the accepted value? That's probably a better word than actual. That's the word your textbook uses. So accepted. Okay, so then what is precision then? Okay, how close they are. David, you're going to say?
Let's say you take a test over and over again.
Mm-hmm. Okay. You get the same measurement repeatedly after multiple times of doing it? Sure. Excellent. Okay. How about our textbook definition? What does it say for us for precision? Yes, sir, please. My apologies. Okay, to one another. So how close? The measurements are to each other, right? So take a look at those little targets that are on the bottom of page 47 there. I think this is a brilliant way to illustrate this concept. They first put this in this textbook about 4 or 5 years ago, and I've loved it because it makes this very obvious, at least to me. I'm not sure how it works for you. Which of these targets, or these pictures there, are showing you something that is accurate? Okay, the first one, just one arrow, boom, right in the center. Any other ones that are accurate? The third one's got a bunch of arrows right in the center, right? Cool. Okay, are any of these precise? Okay, the second one, you got a whole bunch of arrows that are grouped together. And the same with the third, a whole bunch grouped together in the center. What's the problem with number 2? Oh, so we're precise, right? The arrows are all right in the same area. The problem is you're headed for the center and you hit way out on the outside, right? It means, if something's wrong with your sight, you got to recalibrate to get it so that it's in the center, and then you'll hit your target, right? So in science, we want both accuracy and precision. So that Kirsten, in her job in the future as a paleontologist, she's measuring these rocks, and she wants to make sure that she gets every measurement correct, right? She doesn't find the density of gold to be way different than the density it's supposed to have. And she also wants to make sure that every time she measures it, it's correct, right? Precision and accuracy. Make sense? Cool. Let's move on. The next section in this chapter that you read about was about error. Oops, that's an E, an error. So take a look on page 48. We've got some densities there. So 3 different methods, just like what you all did in your lab, by the way. Very similar data. They were doing some measurements. 3 students, student A, B, C. I'd like to know, please, which of these students was most accurate in their average density that they made. Again, this is on page 48. And give me a Y. So you can give me an A, B, or C, but I want to know a Y. Which of these is the most accurate? Accurate. Give me a raised hand. What do you think, Nick? Is it student A, you said? Student C, can you all explain why? Okay, so accuracy is not looking at those errors yet. That's about precision. It's about precision. There's a key point that she said there. What was the actual or the accepted value for this density? 1.59. That says on the top of the table, right? So to find out who's the most accurate, I need to say which of these students is the closest to that number. Does that make sense? So Nick, you weren't wrong. It is A. But the reason why is because student A measured 1.57, right? Student B measured 1.51, student C 1.70. Does that make sense? Our accepted value 1.59, student A is the accurate one. Now I ask you, who's the most precise? Student C? Why?
Because their density seems to be all in the same range.
Okay. How do you know that? Sure, by the data. What part of their data in particular? Their trials, the error that's present there, right? Can you see that each time there's really a 0.02 spread, right? Because they're 0.10, 0.12, 0.11. So they aren't accurate. Are you with me? They're actually the least accurate of all of these students. But they're very precise. They're taking these measurements and they keep getting right around that same 1.70 number. Does that make sense, friends? What we'd love to do is take student A and student C, put them together in a group, and now they'd be accurate and precise. Or maybe they would just both mess each other up. Who knows? But and student B, yeah, they're off in left field, I guess, somewhere. They're not accurate or precise, unfortunately. Are you with me, friends? Cool. And we did some work with error in our labs, right? We calculated your percent error from the density that you measured. Right? It was a very simple calculation to do that, right? We used your experimental value minus the accepted value and divided it by 100, or excuse me, multiplied it by 100 to get your actual error, right? Or percent error. Cool. Let's talk about significant digits over on page 50. I heard y'all did some work on this last year. It's a good thing. Mr. Fuentes is what I heard. Y'all did some work on significant figures, significant digits, I call them both. Because the first book I learned this from was significant digits, and now they call them significant figures. It's fine. Sig figs, right? Exactly. Okay, so there's 4 rules. I know your textbooks list 5, but I'm just going to give you 4. All I did was write just error. Yeah. It's no worries. It's in over there on page 48, 49. Okay, friends, give me some rules for significant figures. Give me rule number 1. What's my first rule? Yes, ma'am. Non-zero numbers are significant digits. I call this rule duh. Like duh, of course. If it's not a 0, it's significant. Okay? So, in other words, if you see a number that's not a 0, it's significant. Okay? Ready for number 2? Okay. All final zeros to the right of the decimal place are significant. So, there are 2 key words there. Final zeros to the right of the decimal point are significant digits. I want to make sure you see that. We're going to do some examples of these. Okay? But again, those 2 key words are final and right. So it means the very last number has to be a 0, and that 0 has to be on the right side of the decimal place. If it meets those 2 criteria, it is a significant digit. Question? Significant digits or significant figures. That's a decimal place. My apologies. DP, decimal place. I'll give you a little better, Carlos. I apologize. The right of the decimal place. How about that? Are significant figures. If you absolutely can't wait, you're missing stuff here. Number 3, what's my next piece? Yes, sir. Any 0 between 2 significant digits. What? It is. It is a significant digit. Yep. So if you have a 0 that's between 2 non-zero numbers, that 0 is significant. If you have a 0 that's between a final 0 and another number, that is significant. Again, we'll do some examples of these. But here are your rules. Okay, all right, number 4. What does number 4 say? Placeholder zeros are not significant. I think it's the stupidest rule in the entire world. Because you have to try and figure out what does placeholders mean, right? So I say it this way. Any other 0 is not a significant digit. If it doesn't meet those 2 criteria, it's not significant. Mm-hmm. Now, your textbook gives you a number 5 about counting numbers and constants that are defined. We'll talk about that in a second. But I'm really worried about these 4, because these are the ones that you'll actually have to use on a daily basis as we're doing numbers in this class. All right, so let's put some numbers up here and see what you think. 0.032. I drew those with a mouse. Isn't that terrible? My handwriting's not that bad. I just can't draw with a mouse. Okay. Let's take a look at number 1, this first 0.032. I want you to close your eyes. Don't fall asleep though, Keenan. And I want you to tell me how many significant digits. Show me with fingers. How many significant digits does that first one have? 0.032. Close your eyes so you're not letting other people affect you. How many significant figures? I see some 2s, I see some 3s, see some 4s. Okay, open your eyes. This is the number. 2 significant figures. Let's go through them. Rule number 1 says any non-zeros are significant digits. Okay? So these 2 are significant because duh. Right? They're non-zeros. Duh. Of course they're significant. And none of you had any doubt about that. The question is these pesky zeros, right? So let's look at our other 2 rules. Final zeros to the right of the decimal place are significant. So, is this 0 to the right of the decimal place? It's not. So therefore, let's cross it out. It's not significant. Okay, how about this one? Is it to the right of the decimal place? It is. Okay, so that meets criteria 1. But is it the final number? Is it on the very end of the number? It's not. So therefore, that's not significant either. So that means when I write this, I just write 32, right? No. Well, let me ask you this. David, I got for you right here in my pocket $32. Would you like that? Sure. How about 3.2 cents? Would you prefer that? No. I can't take either, of course. Any of us would take any money, right? But are you comfortable there's a huge difference between $32 and 0.032 cents? Right? So these numbers are not unimportant. These zeros are not unimportant. They are, anybody? Placeholders. They are showing us where the decimal place is. Yes, ma'am.
I just have a question. So, I get how they're not significant.
Yep.
But, who came up with the fact that, placeholder, aren't significant because they are important? So,
sure.
Who distinguish between important and significant?
So what we do, that's a great question you're asking. What we do in the science world is we don't worry about those stupid placeholder things. We use something called scientific notation to show us exactly what's significant and what's not. I would take this and make it into 3.2 times 10 to the negative 2. And that tells me without a shadow of a doubt, I've got 2 significant figures. I don't have to worry about the stupid zeros. Okay? It's a good question. If this freaked you out, by the way, the scientific notation thing, let me just do a little reminder for you. Because this is negative, right? That means I have a number that's less than 1. And I basically move this decimal place 2 spots to get 3.2. So that's why it's negative 2. It's smaller than 1, so that's why it's a negative number. And we moved it 2 spaces, so that's why it's negative 2. Exactly. If it's a number that's bigger. Now, don't go left and right. Because left and right depends on whether you're going from scientific notation to decimals or decimals to scientific notation. So I don't use left and right. What I use is it bigger than 1 or is it smaller than 1? Does that make sense? How about this one here? Give me some fingers. 2.032. How many significant figures? Don't look at your neighbor. What do you think? Got 2s or 3s or 4s or... Okay, open your eyes. Here you go. 4. We all know these are duh, right? How about that 0? Is it significant? Why? Sir? It's in between 2 significant figures. And that's what rule number 3 says, right? Any 0 in between is significant. So yes. Okay, How about this last one, 1.250? How many significant figures? 4, right? Because 1, 2, 3. And how about that 0? Is it significant? Well, does it fit the rule? Is it between 2 significant figures? No. Okay. Is it a final 0 to the right of a decimal place? It is. So therefore, that is also.
So what would that be?
It would be that exact thing.
What about the
1.250. You could say times 10 to the 0. That means don't move a decimal place, leave it right where it is. But folks usually don't write that. They would just write it as 1.250. It's a good question. Sir?
So if it had been 1.250,
If you put another 0 on the end, it would be 5 significant digits. Because now that 0 would be between 2 significants. The final 0 and the 5. Be 6. Yeah. Because you still have the final 0 on the end. If you put it on the other side, 0.001250, those front zeros would not be significant. Sir?
So couldn't you just add a 0 to the 2.032? How would we know when to stop with the 0?
I wouldn't necessarily encourage you to add more zeros per se. You're just kind of giving them the numbers that you're given. We were just adding like other numbers, like different scenarios, is what he was asking.
So like if we were adding, you would add different zeros if they were given that way?
I'll talk about adding and subtracting in a moment. I guess I'm not understanding your question, Samuel. I apologize.
Because like it says 1.250, the zero's not even needed there.
Ah,
1.25.
good. Excellent. Thank you. I'm with you now. Can anybody explain to me why this 0 is important? We just finished saying it's significant. Can anybody explain to me why it's significant? That last 0, 1.250. Sure. No, it fits the rule. I got you. But who cares? That's what Sam's asking. Samuel's saying, who cares, right? Am I correct? Good. Kay, what do you think?
Doesn't that show that you've actually measured to that decimal place?
Absolutely. So, what were you going to say? Same thing? In other words, Samuel, here, I've measured to the tenths, hundredths, thousandths of a place. And I'm telling you, it is exactly 1.250. If I only measured to the hundreds, then I would say 1.25. If I only measured to the tenths, it'd be 1.3. We'd round it, actually. Does that make sense? So this is telling me how precise I am. The more places after the decimal place, the more precision you have. Sir?
Okay, so those 1.2500.
Yep. They would. Because now this is a final 0, and this 0 is between 2 significant figures, so it would be. Yep. Yes, ma'am. You mean like these two up here?
No, like if you have like 25 and you have like 250.
Right. So here's a tricky one. I gave this to the other class. How about this number right here? 250. How many significant figures is that? It's only 2. Because that 0, while it's the final 0, it's not to the right of the decimal place, right? It's on the left side. So therefore it wouldn't. Now that's where we would use scientific notation, right? To say that that was 2.5 times 10 to the 2. Or if I'd actually measured that, Samuel, to the 1, I would say 2.50 times 10 to the 2. That tells me, hey, I actually measured that 1's place, and it is 250 exactly. Are you with me, friends? It's good. Good questions. These are good questions. The last piece we have together, oops, wrong button, is to talk about what happens when we add and subtract, or we multiply and divide. This is here on page 53. it tells you that with addition and subtraction, and again, I'm just literally going to read you that first sentence. When you add or subtract measurements, the answer must have the same number of digits to the right of the decimal as the original value having the fewest number of digits. So, when you're adding and subtracting, it's always the least number of decimal. Not decimal points, decimal places, my apologies. So, if I'm adding 1.02 plus 2.123, if I'm adding these guys together, right? 3.143, that would be those guys added together. And so in math class, that'd be correct. But in science, we're dealing with the precision of your measurements. And because this is only 2 places, I can only have 2 places there. I would have to just get rid of the 3. I would say 3.14 is my answer. Because that 3, I can't make my combined measurement more precise than that 1.02. Because that's my least precise measurement.
So if it's 1.020,
Yes. If I had 1.020, then I could have added them all together. You're correct. So addition and subtraction is simply the number of decimal places, the least. If I'm looking at multiplication and division, it's the least number of significant figures. Yeah. Yeah, it's on your sheet. It's on here. So with these guys, you're actually looking at how many significant figures do the two numbers have, and whichever has the least, that's what you round to. And again, you're going to do practice. I'm going to give you right now some practice to work on for home. So here it is. On page 51 to 54, you're doing numbers 35 to 44. You've got, again, about 5 minutes here. Go ahead and do some work.